Hello, welcome friends. Me Anila. The topic of my discussion is about combustion of nicotine. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you about nicotine, a organic compound containing carbon, hydrogen, nitrogen. We have to detect this compound by combustion reaction. In combustion, nicotine in the presence of oxygen is burned and form carbon dioxide, water and nitrogen gas. So with the help of amount of sample and amount of carbon dioxide and water, we can detect the compound. Example: 1 gram sample of an organic compound containing only carbon, hydrogen and nitrogen gives 2.71 gram carbon dioxide and 0.776 gram H2O on complete combustion. Molecular weight of compound is 162 gram per mole. Determine the empirical and molecular formula. So in this example, an unknown compound is given, amount of sample is given, amount of carbon dioxide and water formed is given, molecular weight of compound is given. We have to find empirical and molecular formula. We have to detect the compound. Solution. For the detection of compound, we should know first about the number of carbon, hydrogen and nitrogen moles in a compound. For that, we will first calculate moles of carbon dioxide and moles of water. From that, we will calculate moles of carbon, moles of hydrogen, and then mass of nitrogen and moles of nitrogen, and then we will apply the ratios. First, we will calculate moles of carbon dioxide is equal to 2.710 gram as already given in the example divided by 44 gram per mole. It is the molecular weight of carbon dioxide is equal to 0.0615 moles. So these are moles of carbon dioxide. 44 gram per mole is the molecular weight of carbon dioxide because one oxygen has 16 atomic weight and 2 oxygen has 32. One carbon has 12 atomic weight. The total is 44 gram per mole. So we have calculated moles of carbon dioxide. Now, 1 mole carbon dioxide contains 1 mole carbon. So 0.0615 moles carbon dioxide contains 0.0615 moles carbon. So we have calculated the moles of carbon. Now we will calculate moles of hydrogen and nitrogen. Now moles of water is equal to amount which is already given in the example. 0.776 gram divided by 18 gram per mole is equal to 0.0432 moles water, where 18 gram per mole is the molecular weight of water because one oxygen has 16 atomic weight, one hydrogen has 1 atomic weight, 2 hydrogen has 2 atomic weight, total is 18 gram per mole is the molecular weight of water. Now we have calculated moles of water. Now 1 mole water contains 2 moles hydrogen, so 0.0432 moles water contains, we will multiply it by 2 and divide by 1, we get 0.0864 moles hydrogen. So we have calculated moles of carbon in the compound and moles of hydrogen in a compound. Now we have to calculate moles of nitrogen. For that, first we will calculate mass of carbon, that is mass of carbon is equal to 0.0615 moles multiplied by 12 gram per mole. It is the atomic weight of carbon. Amount of carbon is calculated to be 0.738 gram. Mass of hydrogen is equal to moles of hydrogen 0.0864 moles into 1 gram per mole. It is the atomic weight of hydrogen. After solving, mass of hydrogen is calculated to be 0.0864 grams. Now, mass of nitrogen, we have calculated mass of carbon, mass of hydrogen. For mass of nitrogen, we will calculate because the amount of sample is 1 gram. So, we will subtract mass of hydrogen and carbon from 1 gram to get mass of nitrogen. That is 1 gram minus 0.738 gram minus 0.0864 gram. So mass of nitrogen is calculated to be 0.1756 gram. Now we will calculate moles of nitrogen, that is 0.1756 gram. This is the amount of nitrogen divided by 14 gram per mole. It is the atomic weight of nitrogen. So moles of nitrogen is calculated to be 0.0125 moles. Now we have calculated moles of carbon, hydrogen and nitrogen. Now we will apply ratios. Carbon is to hydrogen is to nitrogen. Moles of carbon 0.0615 moles, moles of hydrogen 0.0864 moles, moles of nitrogen 0.0125 moles. Because in all these three values, the smallest quantity is 0.0125 mole. So we will divide by 0.0125. We get 4.92 is to 6.912 is to 1. Because 4.92 is approximately equal to 5, 6.912 is approximately equal to 7, and 1 is equal to 1. So the empirical formula is C5H7N1. So this is the empirical formula or simplest formula. We have calculated empirical formula. Now we will calculate empirical formula weight. That is 5 is the number of carbon atom into 12 is the atomic weight of carbon plus 7 is the number of hydrogen atom into 1 is the atomic weight of hydrogen plus 1 is the number of nitrogen atom into 14 is the atomic weight of nitrogen. After solving, empirical formula weight is 81 gram per mole. We have calculated empirical formula and its weight. Now we will calculate value of N is equal to molecular weight divided by empirical formula weight. We will place 162 gram per mole molecular weight already given in the example divided by 81 gram per mole. N value is calculated to be 2. Now we will calculate molecular formula. It is N into empirical formula. We will put the value of N, that is 2 into empirical formula C5H7N. After solving, molecular formula is calculated to be C10H14N2. So the compound is nicotine. So this compound contains 10 carbon, 14 hydrogen, 2 nitrogen. Compound is nicotine. We have calculated empirical formula, simplest formula, and molecular formula, which is actual formula. So in this way we can detect the compound by combustion. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.